Welcome to General Chemistry Mini Lecture Series, Lecture 5. Today we are going to talk about significant figures. First, let's go over the rules for sig figs. Non-zero digits are always significant, which means when we count the number of sig digits, we have to count them. 235 meters, all non-zero digits. Therefore, there are 3 sig figs. Leading zeros are never significant. So let's say in this one, 0.0057 grams. All of the 3 zeros, they are leading zeros. We don't count them. So therefore, only 2 sig figs. And here, 0.25, the leading zero, it's not counted. So here we just have 2 sig figs again. Embedded zeros or captive zeros, they are always significant. In other words, we have to always count them. So that's why there are 4 sig figs in this measurement and 3 sig figs in this measurement. Okay, because this zero right here, that's significant, and those 2 zeros in the middle, they are significant. Okay, if they are ending zeros, then we need to be careful. You need to pay attention to whether there's a presence of a decimal point. If there is a decimal point, then the ending zeros are significant, like in this one. There's a decimal point is right here, then the ending zeros, these 2 ending zeros, they are significant. That's why 1, 2, 3, 4, that's 4 sig figs. And here, 100 point milligrams, that's 3 sig figs because of this decimal point. So then these 2 ending zeros are significant. However, if there's no decimal point present, so therefore the ending zeros, they are not significant. That's why 400 meters here, so there's only 1 sig fig. 4.0, that's 2 sig figs. 4.00, because of the decimal point, so then that's 3 sig figs, even though they are all mathematically 400 meters, but the way it's presented here, they can have different significant digits or figures. Exact numbers, like the number obtained by counting or definition and so on and so forth, they have no uncertainty. Okay, so significant figures do not apply. Like, for example, there are 250 students in this classroom. That's a exact number. So the best you can do if you really want to give a sig fig, so then you have 2 sig figs. So because there's no decimal point in there. Okay. Conversions, 16 ounce equals 1 pound, and so on and so forth. You cannot say there are 2 sig figs and 1 significant figure here. Now, that's not the way to do it. Okay, so in general, those exact numbers, they have no uncertainty. That's something you need to pay attention to it. Let's work on a few examples. Determine the number of significant digits in a measurement. 255 miles, they are all non-zero digits, so therefore 3 sig figs. 0.0099, 3 leading zeros, non-significant, so therefore only 2 sig figs. Okay, 2.02, that's a captive zero, should be counted, so therefore that's 3 sig figs. 1.8000 grams, there are 3 ending zeros, and you need to take a look whether there is a decimal point. There is one, then ending zeros are significant. That's why 5 sig figs in this case. 21,000 kilometers, no decimal point, so therefore it is ambiguous. Okay, generally we just assume 2 sig figs because of these 2 non-zero digits. Okay, $8, that's what obtained by counting. So therefore, we consider those as infinite numbers. So that's obtained by counting. So sig figs do not apply. Now I'm going to talk about the rules for sig figs when you perform mathematical operations. So first, let's talk about the rule for when you perform multiplication and division. In this case, the result or the final answer should have the same number of sig figs as the measurement with the fewest number of significant figures. Let's take a look at this. 5.02, 3 sig figs. This one, 5 sig figs. And this one, 2 sig figs. So therefore, the final answer we should keep 2 because 2 sig fig that matches here. That's the fewest number of significant figures. All right. Okay, your calculator will most likely give you 45.0118 or maybe even more digits. Okay. So, but we know we can only keep 2 sig figs. So therefore, it's always a good idea to underline the last digit so that you can perform the rounding for the next digit. So in this case, the next digit is 0. Then I'll just drop everything. So the final answer is 45. So 2 sig figs. Another one, a division, 4 sig figs, 3 sig figs. Then we know the final answer. We have to keep 3 sig figs. So therefore, I underline the last digit. And since the one after the last digit in the sig figs, so that's 9 greater than 5. We round it up. That should be 966. All right, so 0.966. 3 sig figs. Yeah, because the result has to have the same number of sig figs as the measurement with the fewest number of significant figures. And in this case, the fewest one is 3. Let's move on to addition and subtraction. Now we follow a different rule. So we don't pay attention to sig figs anymore. Instead, the result has the same number of decimal places as the measurement with the fewest number of decimal places. Take a look at here. 5.74, that's 2 decimal places. 3, 3, and then for the final answer, the fewest number of decimal places, that's 2. Therefore, for the answer for the result, so it has to be 2 decimal places. Again, I underline the last digit and then look at 1 digit after next to it. So then carry out the roundout. Okay. This one, 4.8, that's 1 decimal place. Here, 3 decimal places. Then for the final answer, we should keep 1 decimal place. So again, 3, that's smaller or less than 5, we just drop it. So therefore, keep 1 decimal place, 0.8. That's the correct way of reporting the result when you perform mathematical operations with sig figs. So rounding, that's what you already learned long before you enter the college. So I will just pull them here. You know, of course, if you have a 0 to 4, you just round down, 5 to 9, round up, and so on and so forth. All right? Okay. Now let's do a few more exercises. We need to round each number to 4 sig figs. So it's always a good idea to underline the last digit. If it's a 4, that should be this digit right here. And then pay attention to the digit after that. So 5, of course, we round it up. That should give us 156.9. Here, for B, the same thing. Underline the last digit. Look at the digit just right after that, adjacent to that. So 4, that's lower, less than 5. We just simply drop 4 and all other digits after that. So we should just have 156.8. Here, the same thing. The next digit is 4, less than 5. Doesn't matter whether you have 9 after that. Really doesn't matter. You just drop it. And then 156.8. So the last one here, again, the last digit is 8. And then the one after that is 9. We round it up, 156.9. Okay, so that's how you do with the rounding. This is the end of lecture quizzes. This time we are going to work on number 2. Which of the following sides of the numbers have the same number of significant figures? Okay, we have set number 1, set number 2, and set number 3. Set number 1. Okay, so there's no decimal place, so therefore the best we can do is just count the 3 non-zero digits. So therefore that should be 3 sig figs. And here, the second one, obviously 3 sig figs. The third one, again, there are many trailing zeros or ending zeros, but there's no decimal place, so therefore we can only say 5. That's 3 sig figs. So therefore we have 3 sig figs in number 1, 3 sig figs in number 2, the same in number 3. So therefore D should be the correct answer. If you think this video helps you learning chemistry, so please subscribe this channel. I will see you next time.